Hello, today we're going to do 1-3 exploring real numbers. So as a quick refresher, yes, you need to draw this chart. You don't have to draw every number and you don't have to make it exactly like this. But the thing I want you to know is that starting right here, natural numbers are just 1, 2, 3, 4, 5. They're all positive and they don't include 0. Whole numbers include 0 and are all positive with no decimals. Integers include negative it's called whole numbers and their opposites. So it's 0, 1, 2, 3, 4, and negative 1, 2, 3, 4. It includes all of these. Okay? Rational numbers, okay, are all of these numbers that we already talked about, and anything in between that can be written as a fraction. Okay, so all these numbers can be written as fractions because you can put -7/1 and -6/1 and so on. Okay, but rational numbers are numbers that can be written as a fraction of two integers, okay, but they also can be a decimal that terminates, which just means ends, terminates or repeats a pattern. So for example, 0.25, we know that can be written as 1/4, okay? Any decimal that ends 0.7, all right, or repeats a pattern, so 2, 2, 2, all the way, okay, you would say it's 0.2 with a line over it, or it can repeat a bigger pattern, 0.235, 235. It actually has to do a repeated pattern. Just because it repeats one number does not make it rational, okay? And then when we get over here to irrational, those are decimals that never end. Decimals that never end, okay? So the most common one of these is pi. 3.14, blah, 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 blah. It keeps going on forever. If you put in your calculator and it keeps going on forever and doesn't repeat, okay, then that is an irrational number. Any square root you take that isn't a perfect square, so over here under rational, you could also have the square root of 25, because we know the square root of 25 is 5. But the square root of 3, it just keeps going on forever. And all of these are real numbers. That's all we're going to deal with. You'll deal with imaginary numbers in Algebra 2. I'm not worried about it right now. Okay? So yes, you need to draw this out. Pause this if you need to write it out. It does not have to be perfect. Okay? But you can even just write out some examples of each one, however you want to do it. But you need to know that all natural numbers are whole numbers. All whole numbers are integers and so on. But it wouldn't work the other way. Okay? All right, so name the sets of numbers that each belong. So 23. So 23 is going to go into a lot. It's going to go into natural, and you can abbreviate if you would like. Natural, whole, it's an integer, and it's rational. It is not irrational, it's rational. Okay, so yes, you have to write them all. You can abbreviate, I don't care, that's fine. Okay, -2/3. Now, -2/3 is not a natural number, not a whole number, not an integer. Because an integer is not a decimal, and 2/3 can be made into a decimal. Okay, and so you would just say that this is rational. That's the only one that falls in there. Okay. Which number set is most reasonable for the given situation? I don't always like these because sometimes I disagree, but we're going to do a few anyway, okay? So number 3, number of students on a field trip. Okay, so you have to pick what best fits. So you can't have a fraction of a person on a field trip. Okay, so it's not going to be a rational number, or I'm sorry, it's not going to be an irrational or, you know, 1/2 or whatever. So the best pick would be a whole number. And why not an integer? Because integers cover negatives. Rationals cover negatives. Whole numbers, now someone might argue you can't have 0 people go on a field trip. Well, I guess you could, so I would probably take whole or natural, because I think there's an argument there. But whole number, technically you could have 0 people go on a field trip. Okay. Height of a door frame. Okay, so that can be in decimals, but you're not going to measure something and take it out to 1,000 decimal places. Okay, you're just going to take it, it can be to the 1/2 inch or, you know, to the 1/4 inch or something like that. All right, so you would just say it's a rational number. Okay, so those you might have to think about a little bit, but don't overthink it. Okay. So real quickly, we're going to talk about counterexample. Counterexample is exactly what it sounds like. If you want to prove that something is false, you just have to come up with one counterexample, okay? To prove something is false. You just have to come up with one counterexample, okay? So true or false, true or false, and if it's false, give a counterexample. All whole numbers are rational numbers. Okay, well, all whole numbers are rational numbers. That is true. When you look at our little chart, all whole numbers go on the inside. Okay, now if it was the other way around, you would say false, and you'd have to give an example. Okay, because 1/2 is not a whole number. Okay, but since it's true, you just write true and move on. Okay, all right. Inequalities. So an inequality is a math sentence. Yes, you need to write this. That compares the value of 2 expressions using, and again, this is a review, so that's why we kind of are going over it quickly. Greater than sign, less than sign, greater than or equal to, less than or equal to. Okay. Remember, the alligator or Pac-Man eats the bigger number. Okay, so this is greater than, less than, greater than or equal to, because it has the little equal sign under it, less than or equal to. Okay, it also can include, sometimes, just to throw this in there, you might do this, which means with the line through it. Woo, that's a really bad picture. That just means not equal. And obviously this is the equal sign. Okay, so what you might have to do in this chapter is ordering things from least to greatest with inequalities, kind of knowing which is bigger. Okay, so when you order real numbers, so fractions from least to greatest, there's a few different ways you can do this. Maybe you're really good at fractions and you understand. Maybe you need to use a calculator and make them into a decimal. Whatever you need to do, you need to make sure that you notice that these are negatives. So right away you should be able to know, okay, this is my biggest number because it's positive. So we know right away the 1/12 is going to be our biggest. Okay, so I'm just going to put it right there. We know it's going to be our biggest number. Okay? Now we have to figure out what order, which is bigger, which is smaller for -2/3 and -5/8. Okay, if you don't understand fractions that well, make these into a decimal. Okay, -2/3, and in your calculator you just put 2 divided by 3 and get 0.67, and negative 5/8 is negative 0.625. Okay, if you're still like, well, I don't know what that means necessarily, well, let's take a look. If this is 0, this is 1, this 1/12 right here is really close to 0, so that's 1/12. Okay, so over here, this is negative 1, this is negative 1/2. Okay, so both of these numbers are bigger, or smaller, I should say, because it's on the negative side, than negative 1/2 and negative 1. So you have to decide where they're going to go. Okay, well, negative 0.6, if it was positive, it would be bigger. So since it's negative, it's actually smaller. It's closer to negative 1. Okay, and this negative 625 is actually bigger because it's closer to 0, because we're on the negative side. So things get a little crazy when we're on the negative side. Okay, so again, put it in your calculator and kind of try to figure it out that way. All right, so negative 0.67. Okay, so we have 1/2 is our biggest, so it goes like this. It's kind of eating the bigger number. Okay, and the next biggest would be the negative 5/8. And then the smallest is negative 2/3. You always have to go back and write it. And I don't know that you necessarily need those signs in there. I'm just showing you. Okay, if it just says order from least to greatest, you can just write it from least to greatest. Okay. Okay, so let's talk about opposites and absolute value real quick. Again, this is a review, so that's why we're going quickly. So opposites is the same distance, numbers that are the same distance from 0, so we're talking number line, in opposite directions. It's exactly what you think it is. Okay, the opposite, so what this is saying is that when you have a number line, if this is 0 and you have 6, 1, 2, 3, 4, 5, 6, it's the same amount in the opposite direction. Okay, so the opposite of 6 is negative 6. I'm not going to put equals. The opposite of negative 15 is 15. Okay, it's just you change the sign. It's just the opposite. Absolute value is a little different. It is the actual distance a number is from 0. Distance from 0. It does not matter the direction. Direction does not matter. Okay, so again, we'll take our 6 example. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we have 6 and negative 6. Okay, both of these are 6 away from 0. Okay, so the absolute value of 6 is 6. The absolute value of negative 6 is also 6. The absolute value of negative 100 is 100. The absolute value of 3 is 3. It's just saying how far away from 0 is it. It doesn't matter. It's how many spaces away from 0 is it. It doesn't matter which direction. Okay? So if we have this problem to do, the absolute value of negative 6 plus 4 plus the absolute value of 3, you're going to treat these as parentheses. You do what's in the inside first. Negative 6 plus 4 is going to give you negative 2 plus the absolute value of 3. So we have negative 2 in here, but it's asking for the absolute value of negative 2. So that becomes 2. The absolute value of 3 is 3. So our answer is 5. Okay, so those absolute values are treated like parentheses. I think all I have left is a little joke.